I don't care how many times a developer tells you that software is going to work just like it does in production, just like it does on their local machine, which I've heard many times from developers, right? That is not true. It has to go through this pipeline in order to make sure that things get caught.
I often get the argument that Canary testing and A/B testing and shadow tip releases are bad in production.
Load testing in an environment that does not involve real production servers or real customers, it's just a simulation.
Yeah, that's true.
Yeah.
Okay, so anybody that says we don't need it doesn't actually understand what CICD is.
Welcome back to episode 95 of the Performant Professional. I'm just kidding. We don't even know what episode it is, actually. Hi, I'm Michael Forrester.
I'm Chris McNabb.
I'm Louis Puster.
And here we are going to talk today about, this may sound inflammatory, but this is literally how we talk about this. What is an ideal CI/CD pipeline? How close can we get to ideal, basically software delivery pipeline, CI/CD pipelines? And what tools, processes, and cultures will we need to support this ideal pipeline? So I'm going to kick it off just by saying this. Guys are both looking at me.
We're waiting.
I'm about to poop in your hand.
We're waiting, Michael.
Is that all right? So this came up recently, and so I'm going to keep this really short. Is someone said, "Well, I have AI. I don't need a CI/CD pipeline." And I said, okay, this is September 2025. Claude Code just deleted my entire Kubernetes cluster because I let it go outside of my CI/CD pipeline.
Yeah.
And then, and this is not Claude Code's fault, by the way, because I love this tool. And then it deleted all of my Linux boxes and made them unbootable because I, again, let it go outside of my AMI, basically machine owners per pipeline that I had for provisioning, right? So I want to talk about what we even think an ideal CI/CD pipeline is, right? Like, what is an ideal software delivery pipeline? And then I want to talk about, are they still relevant in 2025? Because I'm getting feedback that people think they are not, actually. So, Chris.
Okay, we're going to have a really short one.
Oh, we are?
An ideal pipeline is whatever the hell you need to make sure that your software gets to production and does so in a way that everything works and provides value. Whatever that is, it's different for everybody. So there's no true ideal. And do you need it? Yes. There. Done.
All right, so we know that you still need it. You still need it for AI.
Yeah, you need it because the whole okay. So anybody that says we don't need it doesn't actually understand what CI/CD is.
What the value is.
Right.
Okay.
Like the whole idea of continuous integration and continuous deployment. Of course, you're going to need continuous deployment. Well, even if AI is doing the deployment, that's still continuous deployment. Unless you're going with the whole waterfall route of I'm going to deploy this thing and I'm never going to touch it. It's never going to evolve. Yeah, it's.
Can you get away with
that? No, you cannot.
Okay. All right, but hold on. So you gave a definition, but it had some really kind of vague edges around it. Louis, what is your definition?
What a good CI/CD pipeline.
What's a good software delivery CI/CD pipeline look like? What does it contain?
So from a business perspective,
yes,
always with business.
Always with the business perspective. From a business perspective, you want the time to delivery to be as short as possible.
Right.
Okay. So that way, code is being written, the team delivers it, and then if it's approved because changes based on the business need.
Fair enough.
The fastest it can get to production, assuming you have approved that delivery, the fastest and safest way that can happen is the best way.
Safest. What do you mean by safest?
Safest is it needs to go through some sort of probably automated, because manual is too expensive, way of checking for certain requirements, mostly security and integrated tests and so on need to be run on it. So that way it can land in an environment safely, meaning it doesn't bring the servers down. It doesn't impact stability. It doesn't cause any
all
problems.
the non-functional.
Right.
Security, reliability.
Yep. So it needs to be delivered in that way. Now, in an ideal situation, because that's what we're talking about, I would make this a frictionless service that the development team can interact with without necessarily needing to pull in a whole bunch of other people to move their software with a massive crane from their development environment into production.
I mean, a self-service platform?
I mean, that would be great if the team can be trusted and empowered to push a button and allow for the code to be delivered to
Wait, has
production.
anyone ever even built a business model off of a self-service platform?
Oh yeah.
Like what? Give me an example.
3 letters.
Go
ahead.
What is that?
AWS.
Indeed. Please continue. Sorry.
Yeah. So like that's kind of the ideal. That's what we should be chasing, is a delivery pipeline that delivers value whenever needed, right? Not at specific times, that quickly delivers, going through a series of checks before it lands in production.
So you mentioned both speed and quality, basically.
Yeah.
Yes. So quickness and quality, basically.
They're both important.
Yeah, I would say that's the real purpose of CICD pipeline, is to speed the development or speed the deployment, but also improve quality or ensure quality.
Or at least flag imperfections, right?
Yep.
Problems, risks, right? Okay.
And so let's talk about 2 different pieces of CICD. And I think this is important for anyone who doesn't know what CICD is.
Right.
Right. Continuous integration means continuously integrating the software over time. Right. Ideally,
the branches folding and all that stuff.
Ideally, you're going to be doing this with as small of batches as possible. The code will be integrated. And the reason for that is if a problem is discovered, if suddenly something is not in compliance for security or other reasons, you know exactly what commit made that happen.
So you're basically saying try to keep it to a single feature change.
Yeah, as small as possible. It can be a single code change. You can commit it. Because the reason why you want to do that is because it makes it so much faster to solve a problem if a problem is found. Right? Because this batch was 3 line changes. It's got to be within that tiny bit of code. And now people can solve that problem without spending hours and hours and hours poring over code trying to figure out what is actually causing the problem.
You and I, by the way, were somewhere recently where they were folding somewhere between 20 and 40 changes, massive line changes.
Wow.
Yeah.
Into basically an integration, right? Which wasn't even really arguably an integration. It was actually a deployment at that point in time.
Yeah.
Because they were just bundling a bunch of features together and then just trying to shove it out.
Yeah.
And then what was interesting, Louis, you made a comment about this at the time, is that they were throwing it over the wall at a huge batch of testers.
Mm-hmm.
And so it wasn't actually, in a sense, going through a testing pipeline. The pipeline was a bunch of human beings.
Yeah.
And so their rate of delivery was
slow, very slow. Yeah.
Super slow.
So if you're making small integration changes, right, that's the CI.
That's the integration part.
Right. And then the deployment, continuous deployment, is the as you need, deploy it to production. Right. There's famous examples, which you guys know much better than I, where companies deploy software to production many times a day.
Yeah.
Right.
Yeah.
Whereas in the old days, it was we scheduled something once a quarter,
3 o'clock in the morning.
3 o'clock in the morning, because the servers might come down. Never do it on a Friday.
Never do it during the day.
Yeah, never do it during the day.
The whole team has to be in the office.
People are on
and
call. You
want
want to try and minimize that because, again, from a business perspective, all of that additional emergency fire drill costs you money and time.
Yeah.
And so by reducing batch sizes, by continuously integrating the code and making sure that it tests and it goes through, and then continuously deploying small changes into your environment to, again, make sure that everything works in production. Because I don't care how many times a developer tells you that software is going to work just like it does in production, just like it does on their local machine, right?
Which Docker didn't solve that?
No. Which I've heard many times from developers, right? That is not true. It has to go through this pipeline in order to make sure that things get caught.
Yep.
And so the ideal for that is to make that as smooth and as self-serve and easy for even non-technical people, I would say, in an ideal world, because then you can give your product owner, you have the control to say when this is deployed.
Yeah.
When are we sending this into production? The business can own that, which is great, because then the developers can stay focused on what they need to do, which is write code, fix problems.
So continuous integration is the folding of the code, merging of smaller changes into a main deployable version of that code, right? And then once that is versioned, right, then we deploy that through the environments, and then we can go to production if we want. There's variations of like continuous deployment, continuous promotion, blah, blah, blah. We're not going to talk about all that, right? I think the distinction, though, is that once you've got a buildable artifact, you are then moving it through the process of getting it to production.
Yep.
in some
Right.
form or fashion.
And I would also point out that part of the pipeline is in fact testing it at each of those stages. It's not
Agreed.
just integrate it and go. It's integrate it, make sure everything's okay, then go.
Okay, so then here's a question for the two of you, right? So an ideal pipeline does at least checks all the boxes, but we're not being prescriptive about tools because
'Cause-
like we had a buddy who used Makefiles with the
Yep.
Jenkins server
Yep.
to deploy, and we were like, what? And he was like, but I just need a scheduler, otherwise it's all in Makefiles. I can do everything I need to right
Yep.
there, right?
And I mean, I've done that myself several times.
we have other people who have sophisticated GitLab orchestrated kind of tool sets that bring in all the tests and run and spin up your performance environments and do all the stuff, right?
Yeah.
So I guess the question there though is that in my mind, and this goes to a little bit to the AI question, those tests are deterministic in the sense that we start out with a test to see if we can merge one branch into another branch at whatever point in time that deployable branch is at. Then we do other tests that once we've got an artifact, then we're going to take that artifact. We've already scanned for security and reliability, other pieces, linting, standards, all the other stuff. Now we're going to take the artifact, we're going to run it, and then we're going to do more tests.
Yep.
And then we're going to do more tests about how it works with other things, not just the units that make up that particular piece of software, but how it interacts with other pieces of software.
Yep. Other APIs, other databases.
Okay, so I haven't said anything out of bounds.
Yeah. No.
And then we might even get to the point where we're going to do actual user journey, user experience tests, especially if it's got a front end to it. But even if it has an API, we could walk through all the APIs and just say, hey, is everything okay? Is it still functioning? Did we add and not mutate anything, which is good API design, right?
Yep.
And then we could eventually get to load tests, right? Where we actually run performance and load tests and stress it and fracture it. And then Louis, you've talked about this a lot before, where it's like, well, then we can get to user acceptance tests where we do demos and we show people what things look like, give them a chance to give fast feedback, take that small batch and iterate it just by giving it over to the customer on the front end. And then we get to production, which could have A/B, shadow releases, all that other stuff to it, right? Do you agree that that's a deterministic pipeline? And by the way, did I miss anything?
I don't think you missed anything. I would say that the order gets a little flexible.
Say more about that.
So the idea of load testing, very often that happens after a certain point and it's already deployed to production because
True.
Load testing can be very slow. And so there's several places in there where the actual testing can be very slow.
Oh, I see.
And so you might want to move it.
Because you're not at
So
the scale
after
that
the-
you would be for production traffic.
Right.
And the cost of running production traffic pre-production could be high.
Could, yeah.
Additionally, any testing that is slow means that it slows down all of the feedback loop, right?
Yeah.
If you can do all of the quick testing first, and if it fails any of those, you suddenly have something that someone can fix.
Yeah.
And you're not wasting time. They're still close to working on that artifact. Hopefully, they haven't moved on to 14 other things. So that the faster that loop can be, the better for everybody.
Okay, so then I had another point, but I want to stay with this one for a second. So then I often get the argument that Canary testing and AD testing and shadow releases are bad in production. And
Really?
the concept, the general concept is this ideal of we don't test in production. And my counter argument is that one, we try not to only test in production.
Yes.
But we always test in production.
Absolutely.
But we should not be only testing in production.
Yes, I would absolutely agree with that because it doesn't matter how much testing you can do, you might miss something, and therefore you're only going to find it in production.
But also to your point, Louis, is that testing at scale is going to slow down the iteration cycle.
Yep.
And I think we could argue, please correct me if this is wrong, that feature releases that satisfy customer needs are probably the greatest thing at speed and at quality are the greatest thing that a software company can do.
Well, there's another piece of this that I don't think you mentioned is that load testing in an environment that does not involve real production servers or real customers is just a simulation.
Yeah, that's true.
Yeah. Well, and like we've had this conversation, like Chris and I, like 10 years ago, we're using Grinder and Gore basically to replicate traffic in production instances. But it got like really costly and it took a long time because the automation wasn't there yet for us to spin everything up. Yeah. My point being, though, is that Canary testing is a totally valid way to test something at scale with a limited risk radius.
Yep.
And I get sometimes a lot of pushback where it's like, we're going to actually test with our users. I was like, you can even create a beta program, offer them some feature or some enhancement for being in the beta program, and test 0.5%, 0.1% of your traffic.
Yep.
And then you can just scale it up as you go. And the answer I usually get is that, well, why would we disrupt the user experience? And it's like, I love that you're on the other side of that, because that's not the common response I get.
Yep.
At the same time, I'm like, you've got to test at scale. You have to test at load. You cannot not test at scale. That's when everything breaks.
So if you do shadow releases and you do Canary tests or A/B testing, and the people know that they're in the A group, right? That they're opting in, like you're talking about. There's lots of ways that you can mitigate disruption, because if they understand they're in this group, they are opted in for it, and they get a preliminary heads up that this is going to happen.
Yep.
Right. It allows for
communication,
again, more communication, but it allows for you to have a better feedback cycle.
Sure.
You can react to problems a lot faster, and you don't have people calling the support center who doesn't believe them that they're having a problem because they can't replicate it, which then delays the ability for you to respond, right? So if you build a program well, you communicate with your customers well, become to somewhat customer obsessed around the releasing of new features and code, you can navigate that pretty well.
Yeah.
But there are so many companies who don't have an opt-in, that do limited releases with Canary releases with small sets of people, and they push out these things.
Yep.
And I mean, even Apple does it with their OSs.
Right.
They will pick a subset of their users and push an update.
Right.
And then other users that find out the releases available can go into their applications and request to be added to that list, knowing that an update's coming. But they do one thing, which I think that all companies really should do now in the modern era of 2025, is they have people who want to report on updates. They want to talk about their updates. They want to put things on YouTube about the updates. They want to review the updates. So they create a creator collaboration, which allows for more people to understand that this change is coming. It's all about marketing. It's all about customer communication to navigate the downtimes or downsides of potential outages or impacts, right? But the thing is that if you do the old school method of everyone's on the same version,
right,
we're just going to push it and not tell anybody,
right,
that is a bad customer experience, even if the software is good and works.
Yep. Yeah. So it's interesting because Louis, it sounds like what you're emphasizing is that there's a relationship there built between the company and the customer.
Well, how do you know what your customers want if you don't have a relationship with them?
I mean, it's surprising, though, that a lot of that becomes remarkably transactional. Yeah. Because, okay, let me ask this question. Who, and you said this earlier, who is the number one customer of a CI/CD pipeline? Who's the primary customer? Chris, what would you think?
I would say the business as a whole, because its entire reputation.
Agreed, but who's the direct user
by
of the
that
CI/CD pipeline?
The direct user of it should be the devs.
Agreed, right? And you
devs and product owners, and
you were advocating self-service, right?
Yeah,
and I agree with that. But how often or not do we find out, like, it's my CI/CD pipeline? This is operations CI/CD pipeline. This is DevOps CI/CD. This is the release manager's CI/CD pipeline, right?
Yep.
This is the product's even CI/CD pipeline, which I wouldn't argue with. I wouldn't argue with the product piece. I wouldn't argue with the business piece. But when we get down to who's actually waiting to see their software go into production, don't get me wrong. I think the product owner eventually finds out about it. Certainly the business does. But the developer's sitting there going, oh, where's my feature at?
So the three of us worked at a company that had a CI/CD pipeline.
Yes.
And if I recall correctly, there was one team in particular that wanted to have more direct interaction with the CI/CD pipeline. The DevOps group made changes and allowed for that to happen, which then created a better experience for the developers and the DevOps people. And they took that model and they started to work on it with the other teams once they got it stable. That right there was the customer experience between DevOps and the developers, as it should be.
Yeah.
They're building something that the business can benefit from by focusing on who is my customer and how do I drive value. Because the developers are thinking about their customer, which is the business, right? And ostensibly, the actual end users based on the products that they're creating. And the DevOps folks were focused on their customer, which were the DevOps people, right?
So it is interesting, though, is that we can all agree that the developers are the primary users / customers of that, right?
Yep.
And yet they're not built by developers and not frequently available to developers. And self-service is not often a thing. Like, to harp on the pipeline in question that we were talking about, it was a Puppet-based set of scripts pipeline, was it not? If I remember correctly?
I don't remember.
Yeah. Did you, Chris? Do you
Yeah,
remember? Yeah.
vaguely.
Yeah, it was Puppet-based. And I just want to say this as an operations person, I would not have thought that the developers would have been able to eat that learning curve around Puppet. And guess what? They did, actually.
Yeah, they did.
They ate it enough.
They did.
To do
but they shouldn't have had
deployments.
to.
They shouldn't have had to. Right? In
Um,
2025, we wouldn't do that. That's the whole thing
Like-
around what platform engineering is all about, right?
And I don't know. You said something in there like the idea that that the devs don't get access to it necessarily, and I've seen that, and I don't understand that because as an operations person, I don't care when the software goes to production. I don't care. I don't want to know. I want to know that the servers are stable,
Right.
but I don't care when the code changes.
But you get called, like, if you were called if the software wasn't functioning, you probably would care when someone else did a release because then that affects
Sure.
your life.
Sure, but
But in that
again,
case,
I would
they
say
were
I
responsible.
shouldn't get called.
Agreed. And I
Like,
think that's an interesting distinction because while we talked a little bit about we're not going to be prescriptive around tools, there is actually checkboxes for the process. People are
Yeah.
always the foundational point for the implementation of technology, right? And so here we are talking about the customer, we're talking about the primary builder of the whole thing.
Yeah.
But there's also all these affiliated downstream people impacting processes that even in 2025, here we are, 13 years later after the the Phoenix project, maybe 10 years later after the DevOps handbook.
Yeah.
And we're still not making people responsible who push the button upstream for the consequences downstream.
Yep.
We're still seeing that. Louis, you and I were working on a project recently where there's a complete separation from the people who give the software to the people who host the software and the people who troubleshoot and support the software. But there is a pipeline, but it's a little broken. The front end doesn't connect all the way to the developers. It's actually handed off to the operations folks who then take the pipeline, execute it, and then when it fails, they go back and kind of surface the errors to the devs, but only after they've rolled the release back in production.
Yeah.
Right. And that kind of thing is still happening across a bunch of businesses. It's like we haven't really understood kind of like the way that we understand like value delivery inside of the system with software. We're still not using CI/CD pipelines appropriately, like in terms of how we're attending to the downstream functions.
Well, I would argue that is not a technology problem.
Yep.
That is not a business problem.
Agreed.
That is not a tooling problem.
Right.
These are people problems.
absolutely.
And in particular, when you see that normally, there's a significant lack of trust, or people don't feel like they're all on the same team, right? They think we're on the DevOps team.
Yep.
We only care about DevOps stuff,
Right.
which means we don't care about anything else that's happening at the organization, right?
And argue their only customer is other people.
Exactly. And the developers can be the same way. We're developers. We don't care about what the QA people are doing. We don't care about what the product people are doing. We don't care about what the DevOps people are doing. That separation is what kills this whole thing, right? Because we can create a frictionless system that allows for developers to push a single button and push their code directly into production, right? And the operations people can live in their own little bubble where they don't even have to interact with the developers. They're just providing this frictionless service and they never talk to each other. But how long before their designs, their implementations, their desires, the outcomes they're seeking get out of sync if they don't stay connected, if they don't realize they're on the same team?
Probably one change.
Exactly.
Yeah, one change.
So
Yeah.
I think fundamentally, right, we come back to the original question.
Yeah.
What does a perfect CI/CD pipeline look like? And what do we need to have in order to implement it? Well, you have to have a culture that allows for you to have many hands in the same pool that desire a good outcome for the eventual customer.
Yeah, the eventual customer.
And it doesn't matter what technology is being used or how many manual steps or automated steps are in the pipeline here. As long as the business is able to succeed based on the system that's created by the people that are putting their hands in the process, and the customer is happy, and they're providing value to the business is providing value to the customer, everything is working as it should. Arguably, you would also want to make sure that everyone is happy in the middle,
Right.
So that they're continuing to provide value and stop, they don't build a culture of distrust and hatred towards each other. So you need to focus on your culture first. Putting technology in when you don't have a culture to support it is just adding additional expense to your business that may not see the outcomes you're looking for.
Yeah, indeed. Yeah, well said. So I also want to point out that the reason I think we're also avoiding the tooling piece is that if we talk about places to host code, arguably, there's lots of places, but only kind of one technology. There's lots of ways to do a build server.
Oh, yeah.
Deployment. There's a lot, like you could even like run your own, right? There's lots of ways to do linting, and there's lots of ways to do static code analysis. There's lots of ways to do dynamic code analysis. The deployment platforms pretty much vary between virtual machines, containers, a la Kubernetes, or serverless, which typically happens on cloud providers. So there's not a lot of variation there. The reason I mention all that, right, because I agree that I think the culture of the different principles and ways that you are going to approach things that then informs the people, which then informs the processes, which then informs the technology, which is actually, I agree, that's incredibly important. Here's the thing I want to throw out there around the AI question, the CI and CD, right? Is that
$5, by the way?
Because I put AI in there. I did it.
I'm going to get a jar.
I'm going to get a virtual jar that we're going to bring up. Is that the issue here? Is that it's like, well, we don't need these processes anymore. And I want to throw this out there because I'm really interested in this. My argument is this: the AI, the Gen AI that we're using now, scales the mountain different ways every time, and 1 out of 20 times it just goes right off the mountain. And if we're treating this as a junior developer with like the same kind of advanced word calculator probabilities that we have with a junior developer, I'm not sure that I would give a junior developer non-self-serving access to a pipeline, right? I don't know that I would give them unfettered access to a pipeline. And the reason I say that is that I feel like they're probabilistic, and a pipeline is deterministic.
Yes.
You're either passing the test, you're passing security, you're not causing problems, you're not breaking the thing, you're preserving the customer experience. I feel like all that's happening. And what's happening now is that regardless of whether you're in infrastructure or applications, I'm getting more and more people are like, I don't need that. I don't need any kind of guardrails, deterministic guardrails around that system.
Right. And that just blows my mind, because we just talked about at the beginning that a pipeline is designed to improve the speed of deployment and the quality of the code that gets deployed. And so they're saying they don't need speed and quality anymore.
Right.
Which is retarded.
My argument is that you can still use Gen AI.
It's very dumb.
Can we do this instead? Can you use Gen AI to generate the artifacts that you're going to stick inside of the pipeline?
Yeah.
Or if it's downstream hooked into an application, can we put guardrails around it, right? So that when the outputs are outputted, it's immediately sanitized for certain keywords, which, by the way, you're seeing AWS, Azure, Google all doing this now, where they're sanitizing output. So they're putting deterministic, programmatic guardrails around this basically probabilistic thing. And what happens is that the outputs can still be widely varied, but within the range of the guardrails that we're talking about.
Mm-hmm.
And so the response I get is that, why would I do that? It's too complicated.
So here's the answer that I this is how I would come back to anybody who says that. I would say, okay, great. You've just given me the inspiration to write an AI that's specific to your needs, that will be sure to include a cryptocurrency miner in all of your code every time you put it anywhere. And you won't know it's there, and you won't know how to remove it. And every time you rebuild your artifacts, it'll put it back in because you don't know what's going on, right? How can you know that the code that's going to production is secure unless you know every step that it's going through? You can't. And if you let these probabilistic things do whatever they're going to do, they're going to put things into your code or into your process or decide not to test.
Which they've done. I've literally seen that.
Yeah, absolutely.
And if that happens, that will hurt your business and it will hurt your customer, and you will only have yourself to blame for it.
So I just want to say this, and Anthropic, I love you as a company, so please do not take this the wrong way. Claude Code had explicit written restrictions at the folder level for the projects, right? At the explicit prompt that was given to it, do not render anything unusable, undeployable. Do not delete anything without asking me. Do not do mock steps and workarounds in the prompts, in the project files, and in the global Claude.md. It said, do not do these things. And it went right off the rails the maybe third time I gave it unfettered access to the cluster. And that was on me. That was on me. That was my
absolutely.
fault,
Because, I mean, the entire thing we were talking about, CICD pipeline, is about guardrails.
It's about standards, right?
Right. It's about keeping things on track, right?
Even
And
within
so
the
if
range.
and so if you remove the guardrails, absolutely, it's going to go off the rails.
Well, so this is the thing. The argument
Just
I'm
like
getting is that
people
we don't
do.
need guardrails. It's smarter than us. It knows more things than us.
That is not true.
And I'm like, but like,
Yeah.
I would say that my counter argument is is if this was a person, you wouldn't do that.
Yeah.
You wouldn't do it for a person. So then why? This could be a whole podcast in itself. Why are we thinking that the AIs are better than us?
Yeah. Why are we trusting AI more than we trust people?
Actually, you talked about this in the very first episode.
Mhm.
Actually, yeah. So I guess bottom line is that what I'm hearing is that yes, you do agree that we actually still need the deterministic guardrails. That hasn't changed because AI hasn't changed anything. All we've done is we put junior developers, arguably, if we're still using that analogy, in place, and they arguably need more guardrails than like a senior staff engineer or whatnot, right?
Yeah.
But regardless, you wouldn't even let your senior staff engineers do it.
That's the thing. Even if the AI was the best developer in the world, it's still a developer. It's still code that's changing. When things change, things break.
Ah, that's it.
And so if you don't have the guardrails and tests in place, I mean, you're going to end up with broken stuff.
It's not even then about the skill or the aptitude of the person involved, or even the level of detail or whatever, or the entity, right?
Nope.
We're talking about AI. It's a change.
It's a change.
Well, here's the other part, right? If you have a deterministic CI/CD pipeline, like you're talking about, where you know what's happening at every step, you know it will be run. It doesn't even have the potential human failure of forgetting to run a portion of it because it goes through the steps on its own and
Right.
gives you feedback. An AI will forget or decide not to do things without telling you,
Yes.
just like a human who might forget
Yeah.
to do a step and push it to production.
Guilty.
Right? I mean, in the old days, that's how things went because it was all manual.
Oh yeah.
And so when we talk about moving to the ideal CI/CD pipeline, I think that we could all agree that we do need automation, specifically to make sure that all of our standards, all of our stability requirements
Mhm.
are all being tested for and accounted for without human error. And by introducing AI, which we know is unreliable, into that mix, you're just putting in the human error instead.
Well, now we've
Right.
got human error, and now we've got AI error.
Right.
Exactly.
Yeah.
So why are we changing that?
Yeah.
Well, I mean, you just called it automation, and like that's a good point because AI is just automation. So why are we deciding that we now have this other part automated, so we don't need the automation that we needed before?
So outside of the fact that complex systems can sometimes give us really unpredictable behavior,
Yeah.
most of our automation can approach that, but doesn't live there. I just want to say that.
Oh yeah.
And the
But-
reason is that we use automation that generally is predictable for us. Otherwise, we wouldn't use it.
That's true.
And I think that's the distinction is that when you said automation, correct me if I'm wrong, you were talking about predictable,
Yeah, I'm talking about like a
flexible,
script.
rule-based
Yeah,
scripts and
Exactly. Right. I understand.
not the probabilistic kind of outcome.
Right, and I agree. But in a lot of the people that might argue that they don't need it, like they look at AI as automation. I'm taking these developer people that I was paying, and now I'm letting AI do it. AI is automating their jobs,
Right.
and like that's
That's what I say.
if you look at it that way, and you are automating, the first step. Why do you think you can get rid of the automation for the second step?
That makes total sense because if
Like-
we're probabilistic and they're probabilistic, and we were putting up guardrails for our probabilistic cells before, why would we remove them when it's just another probabilistic entity?
And even if it was deterministic, even if you could be like, no, absolutely, that this AI or this LLM is going to do the exact same thing every time. You don't know what that change is going to do to any other part of the complex system.
True.
So
True. I have to laugh for a second because I remember having a conversation with a senior staff developer, and I'm not going to miss his name, but I was like, hey, have you ever made like a horrible mistake in production before? And he proceeded to describe him basically running the classical RM-RF star command, right?
Yeah, I do
And
that.
the electrical feeling that crawled up his skin as his entire body basically went into, when he realized that he was deleting the root drives off of some DNS server that was out in production.
Yeah.
That was DNS for the entire like Eastern Seaboard for something. And like when he described that situation and the way it made him feel and the electricity that ran up his legs and how he got goosebumps and he was like, oh my God, and immediately control C and like freaked out and was like, oh my God, I'm going to get fired. And then like, I'm going to fix it. And like the whole thought process that went behind it. And I was like, that's why we need CICD.
Yep.
Because a senior staff developer of 30 years can delete a production server in production. And
One
now, considering
small,
scale we're
innocent
operating at,
mistake.
we can wreck things at scale.
Yep.
That we've never seen before. Like some of the S3 outages that we've had with AWS was a mistake in a text file.
Yep.
Right? A single character. So yeah.
All these systems are extremely fragile.
Yeah.
People don't realize how fragile they are.
Oh my God.
So why would you not want to put protections around them?
Agreed. Okay, so sounds like where we landed. Please add any additional thoughts. Is that one, CICD is one, not necessarily prescriptive because it just depends on the needs of the business, but general agreement is that we've got this automated system that enforces both quality and enhances speed of delivery and is ideally self-service because the number one customer is the developer.
Yeah.
Yep.
And that in the age of AI, we still 100% need CI/CD pipelines because we needed them for human beings. Why would we not need them for AI?
Yeah.
Okay, cool. Anything else to add?
No, I think that's it.
That's it.
Cool. All right, thanks. We will see you in the next episode.
Yeah.